Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue Dave's Defect with Contamination in Web Handling. Messes of all sizes and all sorts are seen across a wide variety of webs and products. Every single separate source must be identified and fixed individually because there are only a few universal root cause treatments. I know your time is precious, so let's get started. Contamination is a common customer complaint on a wide variety of webs and web products. Sometimes it's merely aesthetic. However, we should not treat our coding and printing customers as mere whiners who should be able to put up with a few spots now and then, else we risk losing some of them. As I teach in my problem-solving classes, aesthetic problems are in some ways worse than functional problems because we may not react soon enough or vigorously enough to satisfy our customers. However, when we get into electronics, food, and medical industries, there is no such thing as a small contamination problem. Every identified case may be the cause of rejection of a package, a case, a pallet, a truck, a manufacturing lot, and, in worst cases, an entire line of business. There is a wide threshold of pain between construction products where the spot the size of a coin might be tolerated to electronics where sub-micron size defects will cause a loss of function. This threshold of pain is getting tighter as customers in all industries are demanding cleaner products. So, while the need is clearly there, troubleshooting can be challenging. Contaminants may be hard to classify, hard to measure, and thus making it challenging for QA and process engineers alike to know whether they're making progress. Also, there are likely multiple sources of contamination coming from multiple places. Finally, it may be difficult to fix even when the source is identified. The first principle of good manufacturing practice is to not create disorder in the first place, rather than make a mess and then have to clean it up. There are many sources of contamination. Some of them begin with the very design and layout of your web machine. Dirt can come from the ceiling, and from the floor, and from operators working over the web. All of these are quite easy to avoid, but only at the machine design stage. The first steps in troubleshooting are to collect, classify, and then count. At the high end, collecting defects may include automatic detectors that see and stop the web precisely at a defect. Detectors can be cameras seeing reflected light or transmitted light or some other sensor entirely, such as a magnetometer to detect ferrous metals. In the paper industry, there are optical detectors that are 100% coverage of 10-meter wide webs traveling at more than 2,000 meters a minute. These super smart and super expensive scanners are able to detect and classify defects as small as a mosquito. At the more common level, operators or quality control inspectors will manually look for contamination. While this is usually done at stop, visual inspection can sometimes be done manually at speeds even exceeding 50 meters a minute and even faster with strobe lights or special cameras. Unfortunately, it is your customer that may detect many of your defects. The reason is that they are often running much slower and thus can see contamination easier than you. After you collect, you need to classify the type and size of the contaminants. Sometimes you will know the source by its appearance alone, such as a bug on the web. Other times, you will need to send the sample off for chemical and microscopic analysis. Finally, you will need to count particles in order to determine if you are making progress in contamination reduction. The units would be something like parts per 1,000 meters squared for each contamination type. While we have covered a few examples already, here I will offer my dirty dozen sources. They include the making or converting machine itself, especially the slitting or cutting process. They include, ironically, cleaning the machine using tools that may be both unsafe and inappropriate, such as air wands. They include cellulose or wood-based shipping supplies such as boxes, fiber cores, and wood pallets. Cutting cores is an especially dirty operation, as I teach in my Web201 winding class. Contamination sources also include shipping itself, such as dirty floors and open truck doors. Finally, while we're on the subject of openings in the building, we can mention birds, bugs, and rodents. Finally, we have people, which can bring in crap from the outside on their shoes, and they shed particles of all sizes, from hair to skin to clothing. They are also responsible for many not-so-best practices. One of the many concerns for static charges on the web is its propensity to attract contaminants from the air. Static is well covered in the literature and won't be detailed here. Many people think about cleaning first when they think about reducing contamination. However, this is wrong on so many levels. The first we've already discussed. That is, don't make messes in the first place. The second is that it is difficult, if not impossible, to specify cleaning methods unless you first identify the source and the type of contamination. Identification is the first step to both source reduction and specifying cleaning methods. There are many cleaning methods described in the literature, especially the sales literature. The problem is that much of this is untested. Worse yet, the few methods that actually have been tested and have been shown to actually work only work for a narrow range of contaminant types on a narrow range of webs. So it may be both naive and wasteful to assume that any cleaning method works unless it is first tested on your application. Even if you already have one on your line, you need to test it in order to know if it is working at all, and if so, on what range of contamination it does work on. Until only very recently, there was no published work on cleaning effectiveness that I am aware of by any suppliers or any users of cleaning devices. Recently, however, we have begun to start to see a trickle of peer-reviewed scientific papers on a few of the web cleaning devices. Of course, those were by suppliers, and they were not replicated by disinterested third parties. While the Roysum library is quite complete for literature on web handling and pretty decent on converting, it is not so complete for auxiliary equipment or processes. Thus, I would urge you to do your own searches. Still, from the scores of magazines and conferences I've followed, we have a few articles on cleaning, some of which are actually pretty decent, and much more on static control, even though the static articles do not generally discuss contamination in any detail. Thank you so very much for joining me in this defect solving and defect preventing series. Stay tuned for the next clip where we will discuss one of my favorite defects, core crush. If you found anything interesting or useful here, please like and share and subscribe. Also, please consider supporting the work of this channel using the Patreon link below. See you next time.